welcome to the next lecture in the lecture series of cereal legumes and oilseed process technology. Today we will be studying about methods of grain drying. I am Anshul Dhawan. I will be taking this course. So in case of types of drying or methods of drying, we have different type of drying systems established already that depends on the mode of heat transfer to the grains. See, the classification of grain drying system is generally based on the mode of heat transfer to the material. That can be either conduction, convection or radiation. See, basically we have three types of mode of heat transfer. First is conduction, second one is convection, third one is radiation. Okay, so what happens in conduction, convection and radiation, as you must already have an idea. In case of conduction, so the transfer of heat takes place between two solid contacts. Suppose there is a block A and block B. So the transfer heat, suppose block A is at temperature T1 and block B is at temperature T2, and in case T1 is greater than T2, so the transfer of energy will take place from this block to this block based on this temperature gradient, and that will happen through contact between two blocks. So this sort of heat transfer is called conduction heat transfer. In case of grain drying, what will happen is our grains are in contact with a contact surface or a direct surface which is getting heated and which will transfer the heat to the seed grains. Okay, so which will transfer the heat to the seed grains. So this involves conduction, hence the mode of heat transfer of this drying system will be conduction drying. Second, we have convection. In case of convection, we usually use drying agents like hot gases or flue gases, which will in turn impart or which will in turn transfer the heat to our food material or the food grains by convective currents or convection. In third case, we have radiation. In case of radiation, we use electromagnetic radiation. Electromagnetic radiation which can heat up the surface on which they fall. Okay, so this third method will be a radiation method of grain drying. In this case, suppose there is a very easy example of radiation drying, solar drying. So when you keep your grains in sun, nowadays also this method is very frequently used in developing countries. The grains are spread over the floor in a form of thin layer. So the sun, when the sunlight falls on the grains, they will get heated up and the moisture will remove from the grains, and it will be transferred from this moisture from the grains to the surrounding air. So this method is called radiation drying. We will be studying about them in detail. So based on drying system, grain drying can be divided into these basic three types, that is conduction drying, convection drying, radiation drying, and then apart from these three we have other type of drying, that is chemical drying, and one more, that is sack drying. So this chemical and sack drying can be together, they can be grouped under other methods of drying. Okay. So first we will see about conduction drying. In conduction drying, in this method, conduction is the main principle of mode of heat transfer, and the vaporized moisture is removed independent of the heating media. That is, suppose your grains are coming in contact with a hot surface, some hot metal plate or some any other hot metal surface, irrespective of the shape. Now the heat transfer will take place from the hot metal to the grains. Now since the temperature of grain rises, the temperature of moisture in those grain rises, there will be a temperature gradient established between the surrounding air and the grains. So this moisture, it will get evaporated into the surrounding air. Okay. So the removal of this moisture is independent. The removal of this moisture is independent of the mode of heat transfer. Suppose the drum or the metal on which the grains are coming in contact with, that is getting heated by steam or some other method. So the removal of moisture will be independent. Suppose if we do not remove the moisture, or if we restrict the moisture into the grains, so that there is no moisture content gradient or difference in concentration of moisture content between grains and the surroundings. So the moisture will not evaporate from the grains and will remain as it is, but the temperature of grain will still rise. Okay, so the moisture removal is irrespective of the heating medium. Next is conduction. There are some characteristics of conduction drying here. So first one is heat transfer to the moisture containing solid takes place through conduction through a solid surface. Usually it is metallic surface. Okay. The heat transfer will be taking from a solid surface, which we generally take as metallic, because metals are good conductor of heat. So however, the source of heating could be hot water, steam and flue gases in this case. That is, need not that we are heating the metal directly, or it is the metal which is generating heat. That is not the case. In this case, the transfer of heat is taking place through this metallic surface or solid surface. But the mode of heating of the metal surface, it can be different. It could be either hot water that is coming in contact with your metal surface, or it could be steam, flue gases, or hot oil that is coming in contact with your metal surface and in turn heating the metal, which is drying your grains. Next characteristic is surface temperature can vary widely in this case. Why is it so? Because the surface of grains that is coming in immediate contact with your metal surface, so the temperature of that particular particles of the grains will rise rapidly, or will have comparatively a larger or higher temperature compared to other grains which are suppose not in contact with your metal surface. So the temperature, surface temperature in this case can vary widely in case of grains or your food material that is being dried here. Next characteristic is contact dryers can be operated under low pressure and in inert atmosphere. See, if you maintain a low pressure in case of contact dryers, so low pressures will promote or they will enhance the rate of moisture migration from the grains to the surrounding, and hence they will increase the rate of drying drastically. Why is it so? Because if you maintain low pressures in the surrounding, so low pressure will enhance or they will suck out the moisture from these grains, and moisture migration will be very rapid. The rate of moisture migration from grains to the surrounding will become very high. In this case, the rate of drying will be very efficient and very quick. Okay. Also, it can take place in inert surface. Inert surface is in fact desirable. Why so? If the surface is inert, that is either the contact surface of the metal, it should be inert. It should not react with your metal. It should not react with your food particle. Moreover, the surface or the metal which is coming in contact with your food grains, it should be food grade metal. Okay, like stainless steel. It should be rust proof and should not be toxic. Should not impart any toxic particles to your food grains or any food material which you are drying. Okay. Next characteristic we see is dusty and dusty material can be removed effectively. That is, suppose when you are heating the surface, so the dust, if moisture is present, the dust will cling to the grains. But when you are removing the moisture, the grains or the dust will remain on the surface of the metal, and that can be removed very easily. Next characteristic of conduction drying is, in conduction drying, drying can be made more effective when complemented with agitation. Agitation means, suppose your grains which are in contact with your metal plate which is heated, so only the lower grains will get heated, right? But when you complement this drying process with agitation, that is, you agitate or you keep on mixing your grain particles or your food material which is coming in contact with your metal surface, so this will keep on like exchanging the material particles or the grain particles with the metal. So all the grains or the food material particles will be heated equally. The temperature will rise more effectively, and hence the moisture migration will also take place more efficiently. So when this process is complemented with agitation, that is thorough mixing of the grains, so the efficiency can be increased. The effective rate of drying can be enhanced. So this is an example. This is a drum dryer. In case of drum dryer is an example of conduction drying. Okay. So what is happening is, this is the liquid or the food material which is to be dried. In this case, in case of drum dryer or roller dryer, we are taking a viscous liquid material. So what happens is the lower end of this drum dryer will dip into that liquid. Okay, so the surface which is coming in contact with this liquid, so a layer of this liquid will be deposited on the surface, right? So as this drum rotates, it will form a thin layer on the drum. Now this drum, it is being heated. The inner surface of the drum is heated via steam. Usually steam is used as a heating material for this inner surface of the drum. Okay, so the steam, with the help of the steam, the temperature of the surface can be raised to about 200 degrees Celsius. So when the temperature is such high, this thin layer which is formed at the surface, like this one, so this will get dried very easily. Since it is a very thin layer, the moisture migration from this thin layer, surface of the thin layer to the atmosphere will be very quick. All the moisture or the water will evaporate quickly. So even before this drum has completed one full cycle, see, it is starting from here, the liquid that is coming in contact with the surface. So before it completes one full rotation, up to 3/4, you can say 3/4 of rotation, your material will be almost dried. So you can scrape off this your dried product or dried thin layer using a doctor's blade or a blade to scrape off all the material which has been stuck to the surface. Since we are using an inert surface, so the removal of this dried particle will also be very easy. So with the help of this doctor's knife, this material can be scraped off and can be collected in a container here. Now there are chances that whatever the dried film you are getting here, this will not give you exact powder. So this may further require grinding. So further this may require more grinding. This material whichever is being dried and being scraped off with the help of a doctor's knife. So this scraped off material, there are chances that it will not be fine powder. So whatever material you are collecting here, so further it may require grinding to convert it into fine powder. Okay. So this completes the process of drying. So drum dryer. This is a structure of drum dryer or a roller dryer. And is a very good example of contact drying or conduction drying. Conduction drying is also known as contact drying because the material to be dried is coming in direct contact with your heating surface. So next we move on to convection drying. So as discussed already, convection, in case of convection, convective currents of air or hot air or any other material drying which is being used as a drying agents are used. So conduction drying employs the use of a drying agent, usually hot gases for moisture removal from wet solids by supplying heat and carrying away the vaporized moisture through, thus implementing moisture removal through convection, that is drying. So what is happening? See, in case of conduction, heat was being supplied from a contact surface which was usually a solid surface which is usually metallic. But in case of convection drying, in case of conduction drying, the heat was supplied through a contact surface, but the moisture removal was independent of this heating surface. But in case of convection drying, the same drying agent which is heating your material or which is removing the moisture from the material or the food grains will carry the moisture away from the food grains to the exhaust or the outside the equipment. So the carrier of this moisture content after removal or after heating of your food material or food grains also occurs to the heating medium, which is hot gases or flue gases in this case, which serves as a drying agent. Now this is most popular for grain drying because in case of convection drying, all individual grains can come in contact with your hot gases. So the drying will be more effective and more uniform since individual grain is getting dried. Okay, there is no chance of non-uniform heating. In case of contact drying, the lower surface that was in contact with your heating metal plate was getting heated more than the other particles. But in this case, all the particles of the food grain or your food material, whichever is being dried, is happening, the heating of that particle is happening independently and uniformly. Okay, so next point is we study about the characteristics of convection drying. So under the characteristic, first point is drying efficiency is dependent upon the extent of heat transfer from the drying agent to the grains. Now obviously the efficiency of drying or removal of moisture content from the grains, so it will be directly dependent on how much heat the drying agent or the hot gases are supplying from them, like how much extent, what is the extent of heat transfer for this from this drying gas to our food grains. Okay, so the drying efficiency will depend upon the extent of heat transfer from drying gases or drying agent to our grains in this case. Okay, coming on to the next characteristic, heated steam, flue gases of agricultural waste can be utilized as a drying agent. See, in case of convection drying, what we are the drying agent we are using are hot gases. In this case, either we can use purified gas or like a single gas, either nitrogen which is inert, or we can use our common natural air also. But also in this case of drying, that is convection drying, we can use flue gases from agricultural waste. Like after burning of agricultural waste, we may need to filter it so that it does not deteriorate the quality of the grains. We can directly use the flue gases in this case of drying. Okay, so any gas which is inert, which will not cause the deterioration of quality of our grains, after heating it, so that it has a certain capacity to gain moisture from the product, we can utilize as a drying agent in case of convection drying. Okay. Next point in case of convection drying is drying temperatures are not constant. Why is it so? So this is a sort of drawback in case of convection drying. See, in case of convection drying, when convection currents are formed, there are some hot spots and there are some cold spots. That is, some spots where this drying agent or hot gases can reach directly will be at a higher temperature than our cold spots where this drying gas or hot gases cannot reach. Okay, so there may be disparity between the temperatures in our equipment in this case. So coming on to some other characteristics of this convection drying, the drying rate and the final moisture content of the grains vary depending on the vapor load of the drying gases if the temperature is below boiling point. Now what does this mean is, see, in case of convection drying, all the hot gases or the drying agent or the flue gases that we are supplying, the drying rate or the final moisture content of our grains depend on the moisture absorption capacity of the drying agent. Okay, why is it so? Because suppose you are using moisture laden air at a high temperature for drying, but since it is already saturated, so it cannot hold more moisture. So the efficiency or the rate of drying will decrease. It will not be able to absorb moisture from the surface of the grains, and thus it will not have the capability to dry the grains. Okay, so it depends, the drying rate and the final moisture content of the grains depends highly on the vapor load of the drying gas, that is the humidity of the drying gas that we are using or the hot gases that we are using. Okay, so suppose if the gas, it has capacity to absorb only 1 gram or say 50 grams of moisture, but our grains, they contain 50% moisture, suppose in case of 10 kgs. So 50% will amount to 5 kg moisture content, right? But our air, hot gases which you are using as a drying agent cannot absorb this much moisture content. So after we pass this hot air through the grains, it will get saturated with this water vapors or moisture that it has taken off from the grains. After getting saturated, it will not have any more capacity to gain moisture. So if it does not have any capacity to gain moisture from the grains, so drying will not take place any further, and this will serve as a limiting agent in case of convection drying. Okay, now especially a point is mentioned when the temperature is below the boiling point. Below the boiling point means if our gases are hot enough so that the boiling point of water vapors in our grains is reached, they will automatically evaporate at boiling temperature, right? At boiling temperature, what happens is phase change occurs, that is the water will convert from the liquid state to the gaseous state and will evaporate from the grains. In that case also drying will occur, but If it is below the boiling point specifically, then the moisture content of the drying agent serves as a limiting agent for our drying efficiency. Coming on to the next point, if the atmospheric humidity of the surrounding is high, the drying or natural air drying needs dehumidification. That is, in case we are using natural air from the surrounding for drying, in case of unheated drying system or unheated dryer, what happens is we dry the grain while it is kept in the storage container or storage silos. So in that case, what happens is we are supplying the atmospheric air from the bottom of the storage can or the silo, and it is passed out, or it is thrown out of the silo through an exhaust fan on the top, right? But especially in case of natural air drying, if the air or if the surrounding contains enough moisture, if the relative humidity of the surrounding is very high, so it will not have any more capacity or any capacity to hold any more moisture from the grains. So in case we are using natural air or the surrounding for drying, and the humidity of the surrounding or the atmosphere is already high, so we need an additional step called dehumidification. Dehumidification is removal of moisture. Removal of moisture from the air in this case. So first we need to remove the moisture from the natural air. Okay, after removal of the moisture, so the relative humidity of the natural air or the surrounding air will decrease, right? So it will have the capacity of this natural air to absorb moisture from our food material or our grains will increase. So this, then we can, after dehumidification, we can use the natural air for the purpose of drying. Coming on to the next point, the drying efficiency compared to fuel cost is always lesser compared to that of conduction drying. That is, suppose in case of conduction drying, there is direct contact between your solid or metal surface and your grains or your food material. So the rate of transfer or the extent of transfer of heat from the metal surface to your grains is comparatively higher as in case of convection drying. So it says the drying efficiency compared to fuel cost is less compared to conduction drying. That is, we are using flue gases or we are using hot gases in this case for the purpose of drying, right? But in case of conduction drying, we were using steam or hot water to heat the metal plate. We can also directly connect it to electricity and heat the metal surface. So the efficiency or the heating capacity in that case is more. So the expenditure of fuel in case of conduction drying is less as compared to convection drying. Okay, so in convection drying, a large amount of fuel is needed to provide same heating effect as in case of conduction drying. Hence the drying efficiency to fuel cost is less in case of this convection drying. So next example, in case of convection drying, we can take the example of tray dryer. So tray dryer is a very good example of convection drying system. Okay, so what happens in tray dryer? Here is a schematic view of this dryer. So what will happen is, here we have trays which we fit into a cabinet. Now this is a closed cabinet. Okay, these are all the trays further. So we keep our food grains or food material which we are about to dry, which we have to dry. We fit that, we spread that on these trays. We form a thin layer of this grains or food material so that more effective drying will be there. Thin layer is formed on these trays, and these trays are fitted into this dryer or this cabinet. Now the door of this cabinet is closed and we are providing air inlet from here. That is, air will circulate through these trays, through the surface of the food material that you have laid down in the trays. It will pass over the surface and will absorb moisture. Now if you want to if you want to increase the rate of drying, a heater is also provided. This heater, what it will do is, when this air passes through this heater, it will get heated. So the temperature of this cabinet or the tray dryer will increase. Okay, so as the temperature increases, the relative humidity of this air is decreasing and it has more capacity to hold moisture. Moreover, at a higher temperature, the moisture migration or moisture evaporation from the grains will be comparatively faster. Okay, so all this air that is passing over the grains, these which are kept in this trays, so it will absorb the moisture, and after this has completed, like after this process has been completed, suppose we have kept it for half an hour, and we get in half an hour we get the desired moisture content of these grains. The moisture content is being lowered, right? So as the moisture content decreases and we reach a certain level which is required by our processes, so this air is led through the air exhaust to the outside. Now in this case the air may be supplied continuously, or same air can be recirculated and then let out after the process has been completed. But generally use a continuous air supply and heat the air supply so that more effective drying will take place. This air will be able to hold more moisture, and these are let out through exhaust. Okay, so there is a fan also provided so that circulation of air will be proper. Now our focus here is convection. So air is a fluid, right? So when the air is heated and it passes over your surface, so it doesn't come in contact with each surface, each particle in this case, right? So it is only absorbing through convective currents. As the air passes, it is hot, so it will rise. Now these trays, if they are perforated, so they will rise through the perforations also and will absorb the moisture, will remove the moisture from the grains, and then they can be let out through the exhaust gases. Okay, so this is the case of convection dryers. An example here is tray dryer. Moving on to our next type of drying is next type of dryer. First we will study about types of convection drying. Now in case of convection drying also, we have different type of convection drying based on the mode of placement of grains, or based on the supply of heat energy or the convective gases. So convection drying system, in case of convection drying system we have ordinary state drying, spouted bed drying, fluidized bed drying. So this type of classification, it is based on the state of the grains which are, or state of the food material here which is being dried. So what is happening in case of ordinary state drying, we will read about natural air drying, supplemented heat drying, and heated air drying. So let's continue with these types of convection drying system. So first one is ordinary state drying. See, in case of ordinary state drying, as the name suggests, the grains which are to be dried, or the food material which is to be dried, is in ordinary state or at normal state. What it means is, drying agent is supplied or passes at a velocity much less than terminal velocity of the wet material. Now here in this case, terminal velocity plays a crucial role in defining the types of convective dry. See, the velocity of the drying agent or the hot gases which are passing through the dryer, it plays a very important role. Okay, the velocity, if the velocity is high, more removal of moisture will occur, right? So in this case, terminal velocity is the velocity where suppose if I am passing air, this is a stream of air, right? So here are some grains kept in a bed which is perforated. I'm just taking it as an example. So when this air passes through this bed which has perforation and there are grains in it, so if the velocity of air, suppose here the velocity of air is very less, so what will happen is air will pass through the grains and nothing will happen to the grains, that they will not move. But as you increase the velocity of this heating air, okay, or the hot gases, what will happen is they will start to move the grains. So when this velocity, it produces enough force to lift the grains which is equal to the weight of individual grain. So the grains will start to float in the air. First they will become suspended when this force which this air is supplying, or which this air is applying to the grains, it becomes equal to the weight of the grains. So the grains will come into a suspended form. It will form a sort of a suspension. And if you further increase the velocity of speed, they will start to float in air. Okay. So based on this, we have ordinary state drying when this velocity of air is equal to the terminal velocity of the wet material. Okay. Now there is another point we have to keep in mind. As the drying continues, the weight of grain decreases. So as the weight of grain decreases, at same velocity, which initial velocity, the grain may start to lift up, or this terminal velocity for the grains will decrease as they dry. So you have to keep in mind that this grains, they stay connected to the bread, so to the bed, they do not rise up. Okay. This method employed for delivery of drying agent may further vary as follows. Okay. So first variation in this case comes natural air drying. Okay, what happens in natural air drying? The hot gases or the drying agent in this case is natural air, that is the natural air from the surrounding we are supplying through fans through the grains, as in case of unheated drying. In unheated drying, what is happening is the grains are kept in storage cans or storage drums, and air is passed through the bottom and exhausted through the top of the, or removed from the top of the drum. And it will, when the air passes, if it has ability to hold moisture, if it has ability to absorb moisture from the grains, it will lead to drying of the grains. And the this natural air, after absorbing moisture, it will be laden with moisture, is removed from the top of the drum. Okay, so in first case is natural air drying. In natural air drying, natural is directly supplied to the grains without any modification or treatment. Treatment here means heat treatment or dehumidification. As you have already read, what is dehumidification is? Dehumidification is removal of moisture from these grains. Okay. So in case of natural drying, no modification or no treatment of natural air is required. Normally we are through fans, we are supplying this natural air into the grains. This is natural air drying. Okay. Second is supplemented heat drying. In supplemented heat drying, what is happening is, suppose the temperature of the surrounding air is not enough to heat the grains or remove the moisture. So what we'll do in this case, we will increase the temperature, raise the temperature of this air slightly, that is by 5 to 10 degrees Celsius, so that the relative humidity of this air will decrease and it can absorb moisture from the grains. Okay. So in case of ordinary state drying, we have these three types of drying, that is natural drying, supplemented heat drying, and heated drying, which we have just dealt with. So moving on to our next, okay, so there is a representation of this ordinary state drying. So what is happening is, your grains will be stored in a silo, right? Your grains will be stored in a silo or a storage container. So these are your grains here, or your food material to be dried. So what is happening is, in this ordinary state drying, we are passing this natural air or heated or supplemented air through the bottom. Alright. So let me take this with different color. So this blue color here represents normal air from natural sources, or whatever you are going to use as drying agent in this case. So as this air rises up through these grains, so it will absorb moisture, it will gain moisture from these grains. Okay. So after gaining moisture from these grains, it will move up. Now this air, it contains moisture, it is laden with moisture which it has absorbed from these grains, and it is like removed through an exhaust. Here an exhaust is provided, and from the top, see, you can see exhaust is there here. So through this exhaust you can use this exhaust here for the removal of this moisture laden gases or the drying agent. Alright. So this is an example of ordinary state drying. Moving on to the next, we have spouted bed drying. Okay, now in case of spouted bed drying, drying agent is supplied or passes through at a velocity so that the particles remain in a semi-suspended, almost equal to the terminal velocity of the wet material. So as we have discussed earlier, what is the terminal velocity, right? So in this case, in case of spouted bed drying, okay, so the grains will remain in a state of semi-suspended or semi-suspension. What does that mean is, the air that is being supplied as a drying agent, its velocity is equal to the terminal velocity of the wet grains. Okay, it is almost equal, maybe slightly less, so that your grains or your food particles which are to be dried, they will remain in a semi-suspension. They will not start to float in the bed, and they will not be gathered, or they will not simply lie down at the bottom. They will be in the intermediate state, semi-suspension. Okay, so this is called spouted bed drying, when the drying agent is supplied at a velocity equal to the almost equal to the terminal velocity of wet grains. Okay, so next you can see here. Here is a picture to show this demonstrate a dryer which is based on this type of drying, that is spouted bed drying. So what is happening is, so you are providing hot air here, and this hot air, the velocity of this hot air is equal to almost equal to the terminal velocity of your grain particles. Grain particles are fed through here. Okay, they are stored in here, and there is some outlet here from this outlet, or from this perforation you can say. The grains can come in contact with the hot air or the drying agent which is being entered into the spouted bed drying. Now since in case of spouted bed drying, the velocity of the hot air or the drying agent is equal to the terminal velocity of this wet grains. Okay, all these grains are wet grains. So what will happen? They will remain in a state of semi-suspension. Okay, so when they are in a state of semi-suspension, the moisture content of these grains will decrease, right? And hence the weight of the grains will decrease. So they will, after they are getting dried, or after the moisture has been removed to a desired level or to some level where they become light enough, so they will further move up, and again through this convective currents they will settle down again into the side chambers. So the side chambers, so this is a sort of continuous process. Okay, so after this process has been completed, you will get all the grains at a particular moisture content. Okay, the moisture content of all the grains in this case will be same. Why? Because at that particular moisture content, since all the food grains are of same material, so what will happen is after they reach a certain moisture content, they will start floating and they will accumulate here. When they are here, no further drying is being taken place. So the ultimate moisture content of all the grains will be same. So this is an example of spouted bed drying. Okay. Coming on to the next one, or the third type of convective heat drying system, we have our fluidized or pneumatic bed drying. So as the name suggests, fluidized or pneumatic. Pneumatic means we are applying air pressure. Pneumatic systems are usually designed based on air. See, in industry you have pneumatic conveyors. That is, pneumatic conveyors, they will use air or the air currents or air velocity to transfer particles from one end to the other. So similarly in this case, this type of drying system is based on air which is at a very high velocity, or as you can say, the terminal or the velocity of the drying agent will be more than the terminal velocity of your food grains. Okay. So when the hot gases, that is the drying agent, is supplied at a velocity which is higher than, which is higher than the terminal velocity of wet solid. So that system is called fluidized bed drying. Okay, the drying of wet solid occurs in a suspended or a fluidized state. This phenomena is known as fluidized bed drying. So what is happening here is, see, all the grains are laid over a bed of grains, like over a perforated surface. Now from the bottom of this surface, which is perforated, hot gases or drying agent is passed at a velocity which is considerably very high. So hot gases or drying agent is being passed through this perforated bed at a velocity which is considerably very high enough to, like, the force which this hot gases or air will exert will be equal to the weight of the grains, or even more than that. So if in that case, if this happens, is the grain will start to float. They will be lifted off the ground and they will form sort of a fluidized bed. So as you can see, here moist grains are coming through. This is the bed where the moist grains are stored, and the bottom of this bed, okay, this one. So this one is perforated. That is, air can pass through it or hot gases can pass through it. So when we supply hot gases in this case from here, so this hot gases will pass through these perforations and will come in contact with the food grains or the food particles which are to be dried. Now as they come in contact with this food grains, they will exert some pressure. Since they are at a very high velocity, they will exert a pressure on this food grains or this food particles which will lift them off the ground. Now when this pressure or this force which is being exerted on the food grains is high enough, they will lift the grains off the ground, and sort of fluid bed of grains will be formed here. Why so? Because these grains are floating here. So you must have seen the surface of a ocean or a river. So sort of waves are there, right? When fluid will flow, sort of little waves are being formed on the surface. Similarly, in this case, when these grains are floating, the surface of those grains will appear same as that of water in a river. Okay. Now, after the drying has completed, after sufficient time has been passed, when the grains have been dried and the moisture from this hot air has gained enough moisture, so this dried grains will be removed through this outlet here. Okay, and all the hot gases which we are supplying as a drying agent, after it has absorbed all the moisture content from these grains, okay, it will be removed from the top through this exhaust channel. Okay, all the moist air will be removed through this exhaust channel, right? So this is a fluidized bed dryer, an example of convective drying system, where the velocity is more than the terminal velocity of wet grains. Velocity of drying agent or your hot gases is more than the terminal velocity of wet grains. Alright. So next we move on to the next type of drying system, that is radiation drying. Okay, so radiation drying, one of the most primitive example, one of the most simplest example of radiation drying is sun drying. It is the most primitive one, as you must have or you all must be knowing. What happens is while making of pickles, but first the vegetables have to be dehydrated. So we keep it in sun for drying usually. In developing countries, it is still used as a major method or as the most popular method for grain drying also. So they lay out the grains in open field or open flat surface. They make a thin layer to dry it in the sunlight. So that is an example of radiation drying. So moving on to radiation drying. Radiation drying is based on the absorption of radiant energy with wavelength ranging between 0.25 micrometer to 0.2 meters. So the wavelength or the wavelength of the electromagnetic radiation in this case can vary between 0.25 micrometer to 0.2 meter. So this radiation, they have the capacity to heat the surface through which they will pass, or the surface on which they will fall. They will carry some amount of heat with them. Heat will be carried in forms of photon. So as this light strikes the surface, they will heat up the surface, or as it passes through the surface due to some particular property of polarization, so they will polarize the grains or the water molecules in the grains, which will oscillate at a higher frequency, and due to frictional forces, heating will happen or the temperature will rise. We will read about all this in detail. So radiation drying, it is based on electromagnetic radiation. When it falls on the surface, they heat the surface, or when they pass through the surface or penetrate through the surface, they heat the water molecules which come in contact with them. Okay, so this range includes solar, that is this range from 0.25 to 0.2 meters. It includes solar radiation, infrared radiation, dielectric and microwave radiations. Okay, so all these types of radiation are included within this range. Okay, so next one we see the first method of radiation drying is sun drying. As I have already discussed, the sun drying is most primitive one. Okay, the most commonly used method is sun drying, and since the sun is free, of course, this type of drying will be very economical. Okay, so under sun drying, the grains can be dried under direct sun. Okay, under the sun in three ways. Either we keep the crops, standing crops, in the drying sun, that is, we have not harvested the crops and we leave it out in sun to dry, so that all the stalk along with the seed will dry. So next is method is So the next method is drying of grains in stalk. That is, you cut the stalk and then you keep it in the sun for drying to occur. Okay, so the stalk as well as the grain will dry together. Third will be drying of threshed grains. That means after the grains have been threshed from the crops, they have been harvested from the grounds and separated, then they will be laid out in the sun for drying. So sun drying also can happen in three types. Further, sun drying can be modified, or we can utilize the radiation from sun in a modified manner by using a solar dryer. So in solar dryer you can concentrate the sun and the energy of the sun and focus it onto a particular chamber or in a confined area, so that the rate of drying will increase, the temperature of the food grains will increase comparative to open air sun drying. Okay. A major quantity of grains is still dried by sun in most of the developing countries. Since this is the most cheapest or most economical method, so in developing countries, so this is the most preferred method of drying. Okay, you lay out the crops, you cut the harvest the grains, and then lay out the grains in open sun to dry. Okay, plus the natural air that is blowing over it will serve as a medium for removal of moisture. Okay. So next we see under radiation drying we have dielectric and microwave drying. So in dielectric and microwave drying, a very important property of this radiation, electromagnetic radiation, is being utilized. What is happening is, in drying by dielectric method, it can employ both radio frequency and microwave system. See, microwaves which you use as a common home appliance, it is also based on this radiation drying system. So what is happening is, the molecules of the substance placed in field of high frequency current are polarized and begin to oscillate in accordance with the frequency. In this case, what is happening is, you are keeping your product to be dried in here. So two plates or two electrodes will be there, and you will place your grains or whatever food material you are about to dry, you will place it in between these two electrodes. Now when you switch on the generator or you switch on the supply of this electromagnetic radiation, so this radiation, since this electromagnetic radiation, they vibrate or they propagate at a very fast frequency, that is a large thousand number of cycles within 1 second. So what will happen, the water molecules, since water is a polarized molecule, so it consists of O and 2H. Okay, so H has a comparative positive charge and O has a negative charge. So what is happening is, separation of charge is taking place in case of molecule of water, right? So as the separation of charge occurs, and when this polarized or charged water molecule is placed in this frequency, in high oscillating frequency, whose polarity is continuously changing. See, here it is like this, then it will reverse. So since the polarity is changing, so as per the polarity, the molecule of water will try to adjust itself. It will try to adjust its orientation based on the electric field which this electromagnetic radiation is establishing. In doing so, as this polarity of the electric field by EM radiation, like it can be microwave radiation or radio frequency, as it is continuously changing, so the water molecule, it will also continuously try to change its orientation. Like first, suppose the charge of water molecule is this side, plus minus. Okay, this is water, H2O. Now again, as the polarity changes, it will be negative here. So the molecule will reorient itself. It will change its direction. So in doing so, the water molecule is also vibrating at a very high frequency. It is oscillating. Suppose plus charge, sometime oxygen molecule is coming up, hydrogen is going down, then hydrogen is coming up, oxygen is going down, right? So as this happens, since our product, they contain a large number of water molecules, they will all oscillate at a very high frequency, and they will, in doing so, they will collide with each other. Suppose if you rub two things with each other, what will happen is friction will be generated. Due to this friction, heat is generated. And since this is happening 1000 times per second, so large amount of heat is generated due to this oscillating water molecules, which will very quickly raise the temperature of food product kept in this radio frequency or microwave frequency. Okay, so that is how heating is taking place in this case, dielectric or microwave heating. Now note that because of this high frequency field, the water molecules are vibrating very frequently. The temperature can rise very suddenly. Within a matter of seconds, you can raise the temperature from 0 to 100 degrees to the boiling point. Okay, so this is the principle of dielectric or microwave heating or the microwave drying system. Now comes infrared drying. So in case of infrared drying, see, you all must have used some kind of heater or oven during winter season, right? So what happens is, when you use an electric heater, so some sort of coil will be heated up and orange light will be coming out through it. Now this orange light that is coming out through it contains the infrared radiation. Now infrared radiations which are radiated have the capacity to penetrate a irradiated body. By irradiated body we mean over which this infrared radiation is focused. That is our food grain or the food material to be dried. Now as they are focused onto the product, they will penetrate to a certain depth and will be transformed into heat energy. That is, they will convert their energy to heat energy and will heat up the material. Okay. The infrared heating of foods for moisture vaporization is accomplished by absorption of thermal spectra of electromagnetic radiation from 0.75 to 100 micrometer. See, the infrared radiation here lies between 0.75 to 100 micrometer and this radiation, when focused on the food will heat up the food as it penetrates through it. So this is the basic principle of infrared heating. So suppose we are using some halogen bulb or some this yellow colored bulb. So when you touch the surface, it is heated, right? When you compare this yellow bulb and to a CFL bulb, so the surface of yellow bulb is heated. Why is it happening? Is because infrared radiation along with the light radiation are radiating from that filament. So this infrared radiation, they have a property to heat or to supply heat or to heat the product over which they fall or through which they penetrate. Okay. So this principle is being applied to heat your food grains and remove moisture from them. As they are focused or as they are irradiated, or our food grains are irradiated with infrared radiation, so the temperature will rise, and when you supply some air to remove or some other method to remove the moisture content, so drying of grains will occur in this case. This includes, there are three types of infrared radiation. One is near infrared radiation that lies from 0.75 to 3 micrometer. Then comes medium infrared radiation from 3 to 25 micrometer. Then far infrared radiation from 25 to 100 micrometer. So in case of heating or in case of drying of grains, you can utilize whole spectra of infrared for the purpose of drying. Okay. So next we move on to our next method, that is other methods of drying. So in other methods of drying comes our chemical method, and then comes our sack method. So under chemical method, what is happening is you are mixing your food grains or your material to be dried with some chemical, some hygroscopic chemical which will absorb or which will remove the moisture from the grains or your food material and will gain itself. Let's see them in detail. So in chemical drying, what is happening is food grains have been processed. So these food grains have been processed using various chemicals such as sodium chloride or calcium propionate, copper sulfate, ferrous sulfate. Urea can be used, but it is not used generally. So these chemicals, it should be inert, it should be non-toxic. So they have a property, they are called hygroscopic substances. Now they have a property of absorbing moisture from the surrounding or whichever medium they are mixed with. So sodium chloride here is our table salt or the normal salt that we eat. Okay. So you must have seen in home application also, you mix a salt with certain substance to extend their shelf life, right? Why does that happen? Because shelf life can be extended. If the moisture content of our product is low, the shelf life will increase. The purpose here is same, the principle here is same. Since the salt can absorb the moisture from the grains, so the moisture content of the grains will decrease, right? So their shelf life will be extended. So this principle can be utilized for chemical drying, okay? So salt is mixed with your grains or any other chemical which is inert and non-toxic for consumption, because if we are using this chemical method, some traces of these chemicals will remain in our food, right? So it should be inert and non-toxic. Since they are hygroscopic, they will remove the moisture, they will absorb the moisture from the grains and will absorb themselves. And drying of those grains will occur. The moisture content in those grains will decrease and hence shelf life will increase. Okay. Now next method is sack drying. Okay. In sack drying, this is also like a more commercially used method. In sack drying, what happens is this method is particularly suitable for the drying of. This method is particularly suitable for drying of small quantity of seeds to prevent mixing of varieties and conserve strain purity and viability. That is, this method is generally employed in case when we have different varieties of seed, okay, different varieties of grain, and the quantity is not large enough to process them or to dry them individually. So what we will do is, we will keep all this different quantity of grains in different sacks. We will fill those sacks with different grains, and then what we will do is, we'll see here, the grain bags are laid flat over holes cut onto the floor of a tunnel system so that heated air can be forced up through the grains from this air chamber underneath it. So what is happening here is, suppose this is a ground. Okay, now this floor is there, and in this floor you will cut out some holes into the, you will dig some holes into the ground, small holes, and you will lay this sack of different different grains are filled in these sacks, and these sacks are laid onto this tunnel. Okay, different sacks will be laid onto the tunnel and a heap will be formed, like several layers of this sacks will be there and they will be laid one over the other. Now through a tunnel system, these holes are connected through a tunnel system through which hot air, okay, hot air will be passed into this tunnel system, and as the air passes through this tunnel system, as you can see here, these are the tunnels over which sack have been laid. Okay, like up to 5 to 6 layer of sack you can lay down, and through this tunnel hot air is being supplied. Okay, so this hot air, as it is supplied, it will rise through the holes over which this sack have been laid and will pass through this sack. As the hot air passes through the sacks, it will absorb the moisture of the seeds or the grains which have been filled in the sack, and will remove the moisture from the sack. As the air rises through here, it will absorb all the moisture content of the grains that are filled in the sack. Okay, so that's air, hot air, it is generally exhausted into the, or it is thrown out into the atmosphere after drying. Now you can customize, or you can devise a strategy where if you require less moisture content, those sacks or those grains will be laid in the sacks at the bottom, because the air is hot initially at the bottom, right? So it will absorb more moisture content from those sacks, and as they rise up, so the moisture content removal will be considerably less. So this happens, this is the process of sack drying. As you can see, usually an air temperature, in this case air temperature of 45 degrees Celsius with an airflow rate of 4 meter per minute at 3 to 4 centimeter static pressure per bag of 60 kg is used, okay, for fast drying method. So these are the conditions, that is the hot air that is being supplied here. So the hot air that is being supplied here is at 45 degrees Celsius, okay, and at an airflow rate of 4 meter per minute at 3 to 4 centimeter of static pressure, and each sack should be like 60 kgs. Ideally it should be of 60 kgs, for which these conditions are being used. So this will lead to a very fast and more effective drying of the grains. Alright, so the sack are turned over during the drying process. As I already explained you, the moisture removal will be non-uniform. Like the sack which are in direct contact or which have been laid directly over the holes, so the moisture removal from those sack will be considerably greater than the sack which are laid on the top. Why is it so? Because the temperature of the air when it is coming in contact with the lower sac is higher compared to when it rises up, the temperature decreases. Also the humidity of the hot gases or the drying agent increases, right? So it cannot absorb more moisture from this upper sac. Okay, so they have to be turned over, they have to be rotated so that uniform, if you require uniform drying, so uniform drying will take place in case of sac drying. Okay, so this is the process of sac drying. The sac drying process involves higher labor cost. Why? Because whole sacks have to be laid down, then they have to be turned over in between. So this has to be done manually. Okay, so as it is done manually, the labor cost in this case will be higher. This does not employ any equipment or automation and is done manually, so the labor cost is higher in this case. So that is all in this lecture. Let's just revise once. Under methods of drying, we studied classification of grain drying system. Under classification based on the mode of heat transfer or mode of drying, we have conduction drying, convection drying and radiation drying. And using of chemicals is also involved. So there are other methods like chemical and sac drying. Now under conduction drying, we have studied the principle that heating takes place when material comes in direct contact with a metallic surface or any other solid surface which is otherwise heated with using a other heating system like hot water or steam. Okay, so we took an example of drum dryer here. Next we came on to we studied about convection drying. Okay, under convection drying we studied the drying takes place using hot gases and the principle of convection is involved, and individual grain will come in contact with hot gases and uniform and more effective drying will occur. Also this can be used for thermolabile substances because the contact time is less here. Okay, so on convection drying we took an example of tray dryer. Then under convection drying we studied types of convection dryer or convection drying system, that is ordinary state drying, spouted bed drying and fluidized bed drying. Under ordinary state drying we studied natural air drying, then supplemented heat drying and then heated air drying. Okay, we studied about these in detail. Ordinary state drying, we took an example of normal unheated type of drying. The natural air drying we explained, supplemented air drying in which we raise the temperature just to remove the or just to decrease the relative humidity by 5 degree or 10 degree Celsius. In heated air drying, we raise the temperature of air considerably so that faster rates of heatings are achieved. Then we studied about spouted bed drying. Based on the terminal velocity, these types of dryings have been devised. Like when the velocity of air of the drying agent is less than the terminal velocity of wet grains, it will be called as ordinary state drying. When this velocity of drying agent or hot gases is equal to the terminal velocity of the wet grains, it is known as spouted bed drying. And when this velocity of the air is more than the terminal velocity of the wet grains, we call it as fluidized or pneumatic bed drying. Okay, so after convection drying we studied about radiation drying. Okay, in radiation drying we studied like the heating or drying takes place by employing radiation, heating heating through radiation, electromagnetic radiation. So under this we studied sun drying. Then we also studied dielectric or microwave drying. Okay, in dielectric drying, like polarization of water molecule will take place and it will oscillate at a very high velocity, and heat will be generated through friction when the water molecules collide. Okay, we studied that in dielectric and microwave drying. Then infrared drying, direct heating through radiation. Then under other methods of drying we studied chemical drying. Chemical drying means you applying or employing hygroscopic chemical substances or compound to absorb moisture from the grains or your food material. Then we studied sac drying, that is like when we have different variety of seeds or with different variety of grains and we do not have a sufficient quantity to process them or dry them individually. So what we do is we fill them in different sack and we pile them one over other over a tunnel system where through holes hot air will rise through the sack and will lead to drying of the grains. Okay, so These are all the types of drying system and drying methods that we have studied during this lecture, and we will again meet in our next lecture on cereal, pulses, legumes, oilseed process technology. Thank you.